Hello everyone, I am Engineer Ehsan Ali, MSc student in the Department of Computer Systems Engineering at the University of Engineering and Technology, Peshawar, Pakistan. I'll be presenting the research work which is about blind image deblurring utilizing online platform to estimate real blur in single image blind deblurring. I'll first provide a brief introduction to the topic and the related work, which will be followed by the explanation of our proposed scheme. The details of the results, simulation, and comparisons are given in the experimental setup and results section, while the concluding remarks are at the end of the slides. First of all, let me introduce the problem to you. When we take a picture, we want it to be the exact replica of the natural scene, but due to different reasons like misfocus, motion, or atmospheric turbulence, blur is introduced into the picture, which in some cases like in the field of security, medical robotics and others are very important to be removed, and the picture need to be restored from the degraded image. Degradation in image is due to blur or noise or something both of them. There are different types of blur like motion blur, camera shake blur, out of focus blur, and atmospheric turbulence which causes degradation in the image. There are two types of deblurring techniques called non-blind deblurring and blind deblurring. For the case of non-blind deblurring, the blur kernel is known, while in blind deblurring, the point sphere function or the blurring kernel is unknown and complex in shape, finding of which is a challenging task to do. In our case, the aim was to develop a scheme for estimating the arbitrary shaped point sphere function or PSF, which would be efficient and fast. Here is an example of some related work done. Figure 1 shows three images from a scheme presented by Lee et al. The image on the left is the original ground truth sharp image, and the blurred version of the similar image is shown in figure B. The deblurred image is shown in figure C using the method they proposed. They presented a deconvolution method based on data separation in the frequency domain. The blurred image is separated into a couple of bases and corresponding coefficients. Their proposed methodology works well if there are many blurred images like in video processing, where different frames are to be blurred, which is an iterative process. In such scenarios, this method is computationally efficient because PSF calculated for the first frame is utilized for deblurring other blurred frames. Similarly, figure 2 shows images from the BID scheme presented by the authors, which is learning based and aims at the recovery of artificial blurred as well as real blurred images. The image shown in A is the original image and B is the blurred image, while C is the restoration result using the scheme presented. They used learning approach for restoration and their scheme worked efficiently, but such learning based BID scheme take a lot of time depending upon the amount of image data used for training. For example, deblurring shows a training period of 6 days for 128 x 128 image size and around 1000 images, whereas deblurring algorithm takes only 0.8 seconds. In the case of our proposed scheme, we used Google Colab for our implementations. First of all, the blur image we want to be deblurred is loaded in Google Colab, and then genetic algorithm is used to initialize population. After initial population, the chromosomes are passed through estimation process in which we use BRISC as a fitness function to calculate fitness value of the chromosomes. The fittest chromosomes are survived while the others are eliminated, and the process is then followed by deconvolution using Wiener filter for deblurring. After Wiener filter, the image is checked if it is deblurred. If the condition verifies, then the image is stored to the external file. And if the condition does not verify, then another population is generated and passes it to estimation module. The process is repeated until the condition verifies and results deblurred image. The trust of our proposed scheme depends on two factors, that is PSNR and BLESK scores. PSNR scores were calculated and compared after deblurring for artificial blurred images, which showed how close were the deblurred image to the original image compared to the blurred image. Similarly, for real blurred images, as there are no reference or original image to compare with, so we used BLESK quality score to compare the perceptual quality of the image. An experimental evaluation of the proposed scheme on various degraded images using both artificial blurred and real blurred images were performed. Figure 3 shows the deblurring results using proposed scheme. Column A shows the original images from Waterloo Break Zone dataset, and column B shows the blurred images, while the third column represents the deblurred images using the proposed scheme. The PSNR values were calculated for the images and the results were analyzed and compared. To test the efficiency of the proposed scheme for practical applications, we used real blurred images captured using digital camera affected by motion blur. The proposed scheme's results for both artificial and real blur outdo the benchmark schemes in terms of speed and efficiency. To conclude, the research work aimed to present a fast and efficient blind image deblurring scheme for restoration of blurred images. We presented an improved image deblurring technique based on Google Colab, and for faster results, the GPU on Google Colab was utilized. We compared the proposed system with two other BID schemes, and the proposed scheme estimates the PSF efficiently and faster compared to the benchmark blind image deblurring schemes. Also, the scheme offered is easy, efficient, and fast. Thank you all for your time, and if you have any questions, I'll be glad to answer. Thank you.